Hello everyone, welcome back to Fun Physics Problems. This is part 2 and let's jump right in. So we need to find the escape velocity of the planet Earth. Let's start by drawing it out. And let's draw a little rocket on top. Somewhat badly drawn, but it'll suffice. So what we need to find is the escape velocity of the planet. Let's start by writing down what we know. So we know that F is equal to G m1 m2 by r squared, which is the law of gravitation. G is the gravitational constant, r is the radius of the Earth, and m1 is the mass of the first body, the Earth in this case, and m2 is the mass of the rocket. So we can then find the gravitational energy of the Earth, because the energy expended in the force of gravity pulling the rocket down is just going to be the force times the distance, which in this case is just r. So g m1 m2 by r squared times r would just be g m1 m2 by r. Now the critical insight here is that when the rocket begins to rise, then the kinetic energy, which is the only kind of energy it would possess, is going to be equal to the gravitational energy. And so we know that the kinetic energy is just half mv squared, and because we're discussing the rocket here, that's half m2v squared. And because we know these two are equal, we can write g m1 m2 by r is equal to half m2v squared. And so rearranging, we can cancel out m2, and so you can see that the escape velocity is actually independent of what is trying to take off. So whether it's a fly or an elephant, neither of which can fly, I don't know why I thought of that, but whether it's a fly or an elephant, both would have the same escape velocity, and that's why it's the escape velocity of Earth, not any one particular thing trying to leave the Earth. But anywho, we end up with v square is equal to g m1 by r, 2g m1 by r, or v is equal to the root of 2g m1 by r. And so now we can start plugging in our values. So for this, I'm going to be using g as 6.67 times 10 to the minus 11. m1 is the mass of the Earth, which is about 5.98 times 10 to the 24 kilograms. And r is about 6.37 times 10 to the 6 meters. And so if we plug this all in, we get 11190 meters per second, or about 11 kilometers per second, which is obviously really fast. But that kind of makes sense because the gravitational pull of the Earth is really strong. And it also makes sense as to why rockets have such gigantic compartments full of fuel, because they need to be flying at 11 kilometers per second to actually escape the gravitational field of the Earth. Now, what you'll notice that is interesting is that if you were farther away, then if you were not on the surface of the Earth, but if you were in orbit somewhere here, where this distance is, say, d, then all of these r's would become r plus d. And so finally this energy would actually be lesser. But that's just an interesting point to note. This is the actual solution, and that's all for today. Thank you.